Hello, good afternoon, and welcome to Kobold Letters and Other Mischief, how emails can deceive you. In a world where we taught people how to recognize phishing, attackers would just write more convincing phishing emails. I am Konstantin Weddige, co-founder and managing director of Lutra Security. We are a boutique pentest provider here in Munich, and besides our bread and butter business, pen testing, we try to find some time for security research. And today I want to talk about two results of that. But before we go to that, I want to look at one question. Why does phishing even work? In the end, phishing always exploits trust. The trust of the user in a familiar situation, a sender that the victim believes to know, or in the medium in general. Because after all, why shouldn't I, as a user, trust email or SMS? Zero trust is for network equipment and not for humans. If we don't trust each other, then we can stop communicating and go home. In the end, the success of a phishing attack is determined by whether the attacker can get the user to trust the message enough to do what they want to achieve. Sometimes that's trivial, and sometimes it needs a little bit of help. Common techniques are, for example, creating some kind of time pressure or invoking the greed of the user. In this talk, I want to look at how we can leverage the existing trust of the user in HTML emails and in S/MIME to increase their trust in the sender. Let's begin with HTML emails and have a look at Kobold letters. They got their name from kobolds, the mythological creature that is usually invisible and can be quite a nuisance. They live on ships, in workshops here in Munich, and in people's mailboxes, using conditional formatting to hide or show parts of HTML emails, exploiting the fact that emails allow CSS in style blocks. We will use that to craft an email that completely changes after the first recipient took it and redirected to a second recipient, hijacking the credibility of the first recipient. If you are interested in more details that I can cover in this talk, I have an article on the subject. I'll show the link in the end of the presentation again. Kobold letters affect most email clients, but the implementation depends a little bit on client specifics. It's possible to combine that for multiple clients in one attack, but that would not be very readable on the slides. Therefore, I'll focus on Thunderbird today, but keep in mind, this is not a Thunderbird issue. This is the source code of an HTML email. We have two paragraphs. First paragraph is always visible, nothing special there. And to the second paragraph, we apply the style we define in the style block above. The default is display none, so we hide that paragraph. But if the paragraph is a grandchild of moth text HTML, we will override that and show it again. How does it look? Like we would expect. It's an email with one paragraph. And if we try to forward this email, it looks the same. It's one email with one paragraph that we forward. But if we receive the forwarded email, the hidden paragraph is suddenly visible. And of course, if we want to use that for a full-fledged attack, we are not limited to hiding or showing one paragraph. We can also hide a paragraph when we forward it, and we can replace a whole full email. And the recipient has to believe that the person who forwarded it saw that email, but they never did. I'll talk about how we can use that for a phishing attack in a bit, but before that I want to go to another question. What can we do against it? As we only used standard HTML email features that are commonly used in all kinds of emails, especially in newsletters and notifications, there is sadly no simple answer. I mean, the first option would be to get rid of HTML email completely. And as much as I would like that, I don't think I'll get very far with that idea. I mean, nicely formatted emails are popular for a reason, and this will not change because some security guy says so. A compromise would be to strip complicated styling from emails. Thunderbird does that already with its simple HTML view. This fixes the issue and still leaves us the ability to use some basic formatting. But I still think this is not a solution that is acceptable for everyone. But it is a solution that you can use for yourself to protect yourself. I would love to see that as a default in email clients. So if you get an email, you have a small button, show the email in its full beauty, you click there and then you get all the styling that was intended with the email, like a lot of email clients already do with external images. But probably the best solution would be to get rid of style blocks in HTML emails. This would fix the issue. This would fix another issue, style bleed. I mean, you probably have seen that. You got a colorful newsletter, you try to answer or reply to that, and suddenly your email as well has a colorful background. It's basically the same issue that we exploited with Kobold letters. The CSS affects not only the email itself, but exists in the context of the DOM around it. But this would, of course, break some things. Even though I think if you use it as a post processor and put the style that you use in the style attributes of HTML elements, it's perfectly feasible to do that. But unfortunately, I don't think we are likely to see any of these solutions become widely adopted. The solution for now seems to be me standing here and telling you to be careful. Except there is one email client that almost has a solution. Let's talk about Google Mail. The case of Google Mail is a little bit different than the other clients. If you forward an email with Gmail, Gmail will strip all the formatting from the forwarded email. This allows Google to fix Kobold letters, because they don't have to be afraid of breaking something that is already broken. And in the Gmail mobile app, Kobold letters actually do not work. However, the web app is another case. Because Gmail is stripping all the formatting, it's even simpler. We don't have to bother with the formatting after it's forwarded. We can just hide the paragraph, and Gmail will strip the formatting and automatically show it again. This time, I decided I want to show you how this could look in a real-world example, even with this restriction that Gmail has put forward for us. The email is quite simple. Hello, we had issues to transfer money for the transaction 1234. Could you please forward this to your accountant, Mr. Hacker? That's a simple email with only one goal: to be forwarded. And that something with a little effort should be possible to do convincingly as an attacker. And when we forward it, it looks the same. You see it on the picture below. But wait, didn't I just tell you Gmail will strip the formatting? Yes, but this will only happen after you press the button send. This is how the email looks after it has been forwarded. Can you spot the original email? It's spread out all over it. The transaction ID became an amount, the accountant became the golf partner. And by offering a genuine Van Gogh, I probably pushed the envelope a little bit too far. But keep in mind, this is an email that you would have received from somebody you know, from somebody you trust. And it would be quite obviously for the person who forwarded it to you to detect that it's a scam if they would not know Mr. Hacker personally. So you are in a situation where most people would take at least a small leap of faith. Small detail. I took this screenshot 2 weeks ago after I reported the issue to Google in March, after Google told me in April that they are working on a fix, after they awarded me a bug bounty of 100 euros in June. They should have understood that there is an issue, and they could have fixed it just by stripping the style already when you click on forward and not only when you click on send, like they do in their mobile client. But it's November, it works like on the day when I first reported it. Whatever. Let's leave HTML emails behind and turn our attention to S/MIME. If you thought, let's just go back to good old plain text emails, then we are secure. I mean, I just told you 2 minutes ago that would be a great solution for Kobold letters. I have another attack for you. Salamander MIME. With Salamander MIME, we do not worry about the application layer anymore. We go one step down and look at email encryption. We will exploit the fact that S/MIME, and also GPG for a matter of fact, but I haven't tried that, has no key commitment. This allows us to send an email to multiple recipients, which will be decrypted into completely different emails for every recipient. But before I go into the details, I want to do a quick recap of the attack that inspired me to look into this: invisible salamanders. Invisible salamanders are an attack from 2018 against Facebook's Messenger. They exploit a bug in the message deduplication system of Facebook's abuse system to prevent abusive messages to be reported to Facebook. The attack worked because the abuse system would discard messages, or salamanders as they call them, if the ciphertext looked the same as the ciphertext of the previous message. So all an attacker needed to do was to construct a ciphertext that would decrypt to 2 different plaintext with different keys. This is possible because AES GCM, although it offers authenticated encryption, does not have key commitment. That means the recipient does not know if they have the correct key. Usually, a wrong key leads to some unintelligible data garbage, but you will see that it's possible to construct messages that produce meaningful output with multiple keys. To adapt the idea for S/MIME, we will use AES CBC instead of AES GCM. This is relatively easy to do and will ensure that our attack works with a wide range of email clients. After that, we need to construct 2 emails that we can combine into one ciphertext. And in the end, we will assemble everything into an S/MIME encrypted email and test it. Let's start with a quick recap of how CBC works. The plaintext is XORed with an IV or the previous ciphertext, encrypted with AES and some key, and that produces our ciphertext. This means each ciphertext block depends on only 3 inputs: the clear text, the previous ciphertext, and the AES key. Therefore, this will still work if we use different keys for each block. We can switch freely between keys between each block. And if we try to decrypt this, again, we will be able to decrypt this. If we use the correct key, we will get a readable plaintext block. If we use the wrong key, of course, it will be some garbage, but that doesn't interfere with the good blocks. So we have a message that we can decrypt with two different keys that will contain some readable blocks and some garbage blocks. We will deal with that garbage blocks a bit later, because before that, we have to deal with another problem, padding. smime is using PKCS7 padding, and if that's invalid, clients will detect that and they will reject our message. In the case of key 2, that's not a big problem. We can just add some padding and that's fine. But with key 1, we have the problem that the padding is in one of the garbage blocks. But don't worry, we can fix that too. PKCS7 padding consists of n bytes, and each byte has a value of n, the length of the padding. But for now, the TLDR version is enough. If the last byte of a message has a value of 1, then it has a valid padding. And so far, we have not used the IV. It's just some random value. And if we wanted to build a secure system, that's the way it should be, but we don't really care if it's secure. So if we change the IV, it will propagate through the whole message down to the garbage padding that we are trying to fix. So let's not make it more complicated than necessary. We just try a couple of different IVs, and one of them will lead to a valid padding. It works reliably and is efficient enough. A few hundred tries and it's done. That out of the way, we can look at the messages. We need 2 emails that contain the content that we want to send to the recipients and that can handle the garbage bytes. For the first message, we can use a multi-part alternative email. The first alternative is a text plain email with the content we want to send to the recipient. And the second alternative has a content type text foo. Email clients don't know what text foo is and they will just ignore it. So the garbage bytes will just be hidden as an unknown alternative. And this helps us with something else, because if you remember, we can switch the keys after each AES block. That means the first message has to have a length that is a multiple of the block size. And now we can just add some padding and make it so. The second message is even easier, because email client will ignore everything that comes before the email. So if we don't accidentally have a valid header in the garbage, we don't have to do anything. If we now encrypt the 2 messages using our modified AES CBC, we get 2 keys, an IV and a ciphertext that decrypts to 2 messages. We can now use this to construct a completely standard conform smime encrypted email. The only thing special is that we will include different AES keys for each recipient, but they are encrypted with the private key of the recipient anyway. It completely looks like every other email, and without access to more than one private key, there's no way to detecting this. And because the problem lies in the smime standard itself, every client is affected. However, evolution will show the text foo attachment as an alternative, as an unknown attachment. Kudos for that. Demo time. Does it actually work? If we decrypt the email with the first key, we get what we expect. The email we just talked about, garbage bytes. Same with the other key, garbage bytes, the email we just discussed. If some of you want to try this yourself, I uploaded the files in my article on our website. If we open it in Thunderbird, we only see what we are supposed to see, and we get a green check mark. Same here. Looks trustworthy to me. So, what can we do against it? Not much, actually, at least at the moment. As a user, you can be cautious if you receive emails that are encrypted but not signed, because signing will prevent salamander mime, because you are signing the clear text and therefore making sure that there's only one clear text. But this differentiation will be too much for most users. If you get an email and want to know if it's signed on Thunderbird, you have to click on that green check mark, and then there will be a message that says it's only encrypted, it's not signed. Somebody could have manipulated it, but the message will also say, however, it is unlikely that it has occurred. Most users, it is unlikely, but that doesn't help users to detect this. You could also write some heuristic to look for garbage bytes, but you can only do that after decryption, and it's probably prone to errors. So no email client will do that. The best way to prevent salamander mime would be to introduce key commitment in the next version of S-MIME, and I hope with my contribution I can make this a little bit more likely. Thank you very much.
Thank you so much, Konstantin. Who has a good first question for Konstantin? Anyone?
If you have any question later, feel free to write me an email. I'll try to answer it anyway.
Hi, thanks for the talk. So according to you, your research, which one's more, let's say, difficult to detect, the salamander style or the Kobold style, in terms of incident response?
I think the salamander mime is more difficult to detect because you need to decrypt the message, and you need more than one key to reliably detect it. You could reliably detect it if you have some email encryption gateway. Then you're decrypting all the emails anyway and could cross-check if there is a difference in the key. But besides that, it's difficult to detect. Kobold letters, it's not easy to detect, but you could prevent it by just filtering out more complicated styling.
So your suggestion would be I should stick with salamander style. Thank you.
There you will have the problem that a lot of people don't receive encrypted emails. I don't think either of these attacks will be very popular with attackers, because why bother if you can just write an email, give me your password, and they will do. Tom, yeah? I haven't looked at it, but I think it's possible. Maybe I'll find some time over the holidays or something, but...
We have 1 minute. Any other questions? Over there?
Yeah. Not much. It's really... If you have code trying it, it doesn't take a second. It's no effort that you have to spend there. How much time does it take to encrypt an email? Do it 50 times and that's it.
Okay, that is our time. So please give Konstantin a big round of applause.